A businessman is required to travel randomly between 4 cities every day. After 4 days, what is the probability the businessman will return to Phoenix where he began? One great way to see all the outcomes of the sample space is to draw a tree diagram. So from Phoenix, he can go to any of the 3 other cities. Okay? And from there, let's just call that Minneapolis, Denver, Chicago. Okay? From there, he could go to, well, from Minneapolis, he could go to Phoenix, Denver, Chicago. From Denver, he could go to Phoenix, Minneapolis, Chicago. And from Chicago, he could go to Phoenix, Minneapolis, or Denver. Okay? Let's focus on the middle branches. This is going to get pretty complicated as we go to 4 levels deep of branches. So from Phoenix, he could go to, again, Minneapolis, Denver, or Chicago. From Minneapolis, he could go to Phoenix, Denver, or Chicago. And then from Chicago, he could go to, I know we're running out of space, Minneapolis, Denver, or Phoenix. So we're 3 branches in, quickly running out of space, but we know from here, from the Minneapolis, he could go on his last step to Denver, Chicago, Phoenix, or he could go from Denver to Minneapolis, Chicago, or Phoenix. And from Chicago, he could go to Minneapolis, Denver, or Phoenix. D. Out of these, we have 9 times 3 branches. At each of the 9, we've got 3 scenarios in orange. So 9 times 3 equals 27 for this middle level of branches. Well, how many of these 27 actually end up back in Phoenix? Well, that could be P, P, P. Okay. It could be that one ending in P, or that one. Or it could be that scenario or that scenario. Essentially, any of the outcomes here in orange that have P's in them. Well, that looks to be 7 in all. So there's 7 out of 27 ways he could end up in Phoenix if he went down the middle branch toward Denver at first. But he didn't have to go the middle branch toward Denver. He could have gone to Minneapolis or Chicago, each of the other 2 branches along our tree. The outcomes for each branch would be exactly the same. They would also be 7/27's probability, which means in all, our probability of returning to Phoenix after 4 days is 7/27. There's another way to look at this problem too that might be more comfortable for you. A second approach might be the following way. We look at each day and ask, what's the probability he comes back to Phoenix? So if we look at that, we have days 0, 1, 2, 3, and 4. So at day 0, for each day, we're going to look at the probability he ends up where he began, in Phoenix. Okay? So the probability on day 0 when he starts of being in Phoenix, well, that's 1 because he's already there. It's certain he's going to be there. And the first day, he can travel to any of the 3 cities, which means the probability of being Phoenix is 0. He must travel to a different city. The second day, what's the probability he comes back to Phoenix? Well, if I'm at Minneapolis, I could essentially go to Chicago, to Denver, or back to Phoenix. So it's essentially a 1/3 probability he returns. And that's also true if he's sitting in Chicago or Denver. So in total, he's got a 1/3 probability of returning in the next day to Phoenix, given he's not in Phoenix anywhere. Okay? Well, what about day 3? Day 3, there's a 1/3 chance he's in Phoenix, and there's a 2/3 chance he's somewhere else not in Phoenix. So if it's a 2/3 chance, in other words, he's anywhere not in Phoenix on day 3, there's a 1/3 chance he's going to go back to Phoenix. And if he's in Phoenix, well, for day 3, there's a 0 chance he's going to end up at Phoenix. So we don't care about that, but we know there is a 2/9 chance on day 3 he's in Phoenix. Well, okay, that means there's a 7/9 chance that he's not in Phoenix on day 3. So if he's in any of the other cities not in Phoenix, that again means he's got a 1/3 chance of going back to Phoenix from somewhere else. So on day 4, there's a 1/3 chance he goes back to Phoenix. And the 2/9 chance that he was already in Phoenix, well, he would have to go somewhere else. So that's essentially 0. So the answer to our question in this approach says there's a 7/27 chance, or 7 divided by 27 probability, that he will end up back in Phoenix at the end of day 4. The exact same answer as before.